All right, in this video, we're going to be doing implicit differentiation. But we're going to focus on the second derivative. So when we're doing implicit differentiation, the first derivative we write as dy dx. The second derivative we write as d2y dx squared. And we can talk about where that notation comes from in class. I don't want to put it on the video and make the video longer. All right, so for our first example, we're going to say find d2y dx squared for y squared equals x squared plus 2x. So to find the second derivative, you first need to find the first derivative. So I'm going to go ahead and say the derivative of this would be 2y dy dx equals 2x plus 2. And then we have to solve for dy dx. So I'm going to go ahead and say dy dx is 2x plus 2 over 2y. Now each of those terms has a 2 in it, so I can think of that on the top as having like a GCF of 2 that I can factor out over 2y, and then I can say that those 2's cancel. 2 divided by 2 simplifies to become a 1. So I'm going to go ahead and say the first derivative is x plus 1 over y. All right, so now for me to find the second derivative, I need to do the derivative of the first derivative, right? So I'm going to say my second derivative, and this would be a quotient rule. So I'm going to say low d high, so the bottom times the derivative of the top, minus the top times the derivative of the bottom, and the derivative of y is just 1 dy dx, divided by the bottom squared. Okay, so I have a little bit of cleaning up to do, and one thing that we need to do before we go much further is I can see that my first derivative is x plus 1 over y, and I can see that that first derivative shows up inside the second derivative. So I'm going to go ahead and take this and substitute it back in a second derivative. Okay, so I've got y times 1 is y minus x plus 1 times, and then I have that derivative right there, so that's x plus 1 over y. And then all of that is divided by y squared. All right, so now what I'm going to go ahead and do is I have this complex fraction. I'm going to simplify so that I don't have a complex fraction anymore. So I'm going to multiply by y, that common denominator. So I'm going to say times y over y. And so if I distribute that to the first term and the second term, y times y is y squared. And then I've got minus, and then y times this piece right here, this y would cancel with that y, and I just have x plus 1 squared. On the bottom, I have y multiplied by y squared, which is y cubed. All right. Now, before I decide that I'm completely done, I need to go back and look at the original function and see if there's any substitutions that can be made. So, and this is the step that if I was a student, this is the step that I would forget. So if you look back at the original equation tells you that y squared is x squared plus 2x. And if you look in your second derivative right now, we have a term that says y squared. So what we need to do is we need to do a substitution where we say that y squared equals this stuff. And so I'm going to plug it in for y squared. All right, so my second derivative equals x squared plus 2x minus, now I have x plus 1 squared, but since I've made this substitution, I think that maybe if I was to FOIL this out, some of the stuff would cancel. So I'm going to go ahead and FOIL it out over here. I've got x times x, x times 1 times x, and then 1 times 1. All right, so I've got x squared plus 2x minus x squared minus 2x minus 1 over y to the third. And those cancel and those cancel, and I get that the second derivative equals negative 1 over y to the third. And technically, if you wanted, you could take that y to the third and break a y squared out of it, kind of say it's like y squared times y, and you could replace that y squared with this, but that doesn't necessarily make your answer look any more simple, which is why I kind of left it. All right, so I'm going to say that that is the end of the problem. Okay, here's the next problem. We're going to say find the rate of change of the slope of y squared plus 2y equals 2x plus 1. And so if we're finding the rate of change of the slope, when it says the slope, they're talking about dy dx. When they're talking about the rate of change of that slope, they're talking about d2y dx squared. So they're talking about the second derivative there. So we're going to go ahead and walk ourselves through that process again. So the derivative of this, we would say that is 2y dy dx plus 2 dy dx equals 2 plus 0. So I can go ahead and factor out that dy dx. And then to solve for dy dx, I can divide those parentheses over. And again, I can factor that the bottom has a GCF of 2. And the 2's divide to make a 1. And so our first derivative is 1 over y plus 1. All right. So I'm going to say my first derivative is 1 over y plus 1. So to find my second derivative, I need to do the quotient rule, which you'll find is pretty common with these. So, and that's because we often isolate that dy dx and then divide something. That's why it's very common. So I'm going to do low d high minus high d low, and the derivative of the bottom is 1 dy dx divided by the bottom squared. All right, so in here I can see that I have the first derivative right in there. And so I need to replace that with the first derivative. So this is going to be substituted in. So y plus 1 times 0, that just zeroes out. And so I get negative 1 times the first derivative divided by y plus 1 squared. And if I want to get rid of the fact that this is a complex fraction, then I can go ahead and say I'm going to multiply by y plus 1 over y plus 1. And so on the top, when I multiply this, it's just one term. So when I multiply it, it's going to cancel with that. And so I'm just going to get the negative 1 on the top. And then when I multiply the bottom, I'm going to get y plus 1 to the third. So that means that my second derivative is negative 1 over y plus 1 to the third. And before I decide I'm finished, it looks pretty simple, so I'm probably finished. But before I decide, I need to go back and look at the original problem and just make sure that there's no substitution that I could make. And when I look back at this original problem, I don't see any special substitution. So I'm going to go ahead and say that was my second derivative, which means that this is the rate of change of that slope. So this was the slope and this was the rate of change of that slope, or the second derivative.